Hi, I would like to present what I did on hardware abstraction. This project was broken down into three tasks. Task 1, which is coupling using ROS topics. Task 2, which is coupling using services. And task 3, which is coupling using action goal. Uh, task 1 and task 2 use this architecture, while task 3 uses a different architecture. So on this architecture, you can see that there are three components: a hardware observer running on a PC, hardware controller 1 and hardware controller 2 nodes running on an Arduino. Well, running on two different Arduinos. The hardware controller 1 reads a potentiometer value and publishes that to a hardware observer node via ROS serial. The hardware observer node converts that value into a servo angle and a PWM value for the LED 2. It also publishes the PWM value to the LED on the hardware controller 1. Looking at the code, on hardware controller A, which is hardware controller 1, it reads a potentiometer value and it evaluates if the current value is not the same as the previous value to avoid publishing unnecessary data. Then it publishes that value, and it also subscribes to an LED message which contains the brightness of an LED or PWM value, and it writes that value to an LED. On the hardware controller B, it subscribes to an actuator message, and that message contains a servo angle and a PWM value for the LED. On the hardware observer node, it was designed in such a way that it can be used for task 1, task 2, and task 3. So this is more like making it reusable. So for task 1, the configuration is done here, and this node has a callback called sensor callback. So it gets the sensor value, which is basically the potentiometer reading, and converts that value into PWM values with the function get increasing intensity and get decreasing intensity. It also gets a servo angle using the function get servo value. Then in the publish command, it publishes these messages, and now I'll show you how this functions in real life. So first I start the program. Oh, okay, the program is already up and running, and now when I rotate the potentiometer, it should respond as expected. So now the potentiometer is at max position, and you can see that the yellow LED turns on to full brightness. So this indicates that the percentage is above 90 degrees and less than or equals to 100%, sorry, not degrees. And when I rotate the other direction, when it gets to a position less than 10 percent, then the yellow LED goes off and the red LED turns on, Also, you can see that the servo rotates to max angle and to mean angle depending on the percentage of the potentiometer. Also, I printed values. So these are basically values from the potentiometer reading, and this is executed on the hardware observer node. You can also see values for the LEDs and for the servo angle. On the RQT graph, you can see how each node interacts with each other and what topics they are using to communicate with each other. And that's it. Thank you for watching.